In this tutorial, we're talking about power. Power is the rate at which work is done, so it is how fast you are doing the work. So our equation is, since it's a rate of change, power is work divided by time. But remember that energy is the ability to do work, so energy and work are related. Work creates energy, and energy can be converted back into work. So they are equivalent in most circumstances. And so the power is also the amount of energy used per unit time. Our units then, we're going to skip down here a little bit. Our units then is work, which is joules, divided by time, which is seconds. So we call a joule per second. We abbreviate that as a watt. Go to another slide here, a joule per second. Now remember, a joule is an abbreviation of a Newton times a meter. And a Newton is an abbreviation of a kilogram times a meter per second squared. And so we eventually get that a kilogram times a meter squared per second cubed is also referred to as a watt. When they talk about wattage, it's really an abbreviation of a kilogram times meter squared per second cubed, which, as you can see, is not a very nice unit to write down or look at. So they give an abbreviation of it. It is referred to as the watts. So what does this mean to have a certain wattage? We've seen these before in things like light bulbs. And so if a light bulb has 60 watts versus a light bulb that has 100 watts. Well, what does this mean about the light bulb? Well, this means that the light bulb uses 60 joules of energy every second, as compared to the 100-watt light bulb that uses 100 joules of energy every second. Because the 100-watt light bulb uses more energy each second, it burns brighter. But unfortunately, it also means that it costs more. Because it is using more energy, and we pay for energy usage when we're paying our electric bill. Now, looking at that relationship again, where power is work divided by the time, if we write this out, remember work is force times distance times the cosine of the angle. But let's just say for the ease of calculation that it is moving in the same direction as the force. And so therefore angle is 0 degrees and the cosine of 0 is 1. So multiplying anything by 1 is just the same as the value we had before. So now if we look at this relationship here, F times D divided by T, distance divided by time, well, we know that to be the speed. And so power can also be written as force times speed. And that is the second equation down here. Power is force times speed. So if you haven't noticed already, we're using the letter P for power. And it is a scalar quantity. It has no direction. We don't talk about the direction that the power is going. To talk a little bit more about power and what that represents with the work divided by time is how fast the work is done. It is not telling us how much work can be done. Most times when we think about power, we think of horsepower. And we think about the horsepower of something like a car. So in dealing with horsepower, let's say we have two cars. One has a power of, let's just say 150 horsepower, and another car has 300 horsepower. What does that mean? Well, it doesn't mean that this car, we'll refer to them as car 1 and car 2. It does not mean that car 1 can't do as much work as car 2. They can do the same amount of work. For instance, if we're driving up a hill, both cars can drive to the top of the hill. They can both do the same amount of work. However, the more powerful car can get to the top of the hill faster. And so again, power is simply saying how fast the work can be done. Not saying how much work can be done, but how fast it can be done.